Welcome to lecture number 3 of our MATLAB for Beginners series. In this session, we will dive deeper into some of the most commonly used MATLAB commands and uncover the accurate ways to declare and manage variables, arrays, and functions. Many new learners and even some experienced programmers often face unnecessary errors because of small mistakes in declaration, formatting, or syntax. This lecture is designed to give you a clear and practical understanding of how to correctly declare variables and arrays, common mistakes in command writing and how to fix them, correct declaration methods for functions in the command window, step-by-step error removal techniques to save time and avoid confusion, practical tips to strengthen your MATLAB programming concepts. The best way to learn is by practicing along with me. All you need to do is follow each example by the commands in your own MATLAB command window and repeat until the concepts become second nature. By the end of this lecture, you will not only know how to use these commands but also how to troubleshoot errors instantly, a skill that most beginners struggle with. I will also include a list of commands used in this lecture in the description box so you can easily access them and practice as much as you want. Whether you are starting from zero or brushing up your MATLAB basics, this lecture will guide you in the easiest and most beginner-friendly way. Let's get started and make MATLAB programming simple and error-free. As I told in the previous lecture that MATLAB offers many predefined mathematical functions and also a number of constant values that are also predefined. Let's try some of them. Like in MATLAB, there is a constant value like pi. If we write it, we will find that its value is 3.1416. And if you know cos pi by 2 is 0. But if we write it here, like in this way, we will find its value is not the one that is the cos pi by 2 value. To get the symbolic representation of pi by 2, we will have to write sim and then pi by 2 in this way. But you know that it gives us error. So the exact symbolic representation is to write string to symbolic representation. And it gives us the exact answer of cos pi by 2. When we write pi by 2 in commas, then it behaves like a string, not a constant value pi by 2. The easiest way is to use it without commas. And then see, its value is exactly cos 0. It gives us the exact value of cos pi by 2. In mathematics, we have learned the complex numbers and we can represent them like in this way, that is equal to 2 4j. So I and j are predefined built-in constant values in MATLAB. We can also write it as I. And another value is infinite. It's also predefined. Create array of all infinite values. So its value is infinite. Another value is, for example, if you write it as 3 by 0, then it gives us infinite. And if you write 0 by 0, it will give us NaN, means not a number. These are unique variable names in MATLAB. We cannot use these in declaration of variables. Let's try it. For example, give it a value 7. Yeah, you will find that its value is now changed to 7. But you should avoid these type of declarations because pi is already predefined in MATLAB. If I use the pi value in cost function, then it will give me error. It gives the pi the new value, but to remove the previous value of pi, I have to clear pi and then try it. Again, this value it will give me the exact answer. Using single quotation marks, we can create a character. For example, C is equal to H. So it's stored in C. We can even declare a character vector like hello world. Here I tried some examples like if I check what is inside the C. So we find that C contains the character H as we have inserted H in C. And when I store 14 value to H, it will give me the exact value of H. Mean 14 is saved in H, it's capital H. But don't be confused with the variable name and the character name. So if we find that what is in C, so it will give me only the H. It will not give me the value of H. The double quotation marks can be represented for declaration of strings. Just I tried it. Welcome to my channel. The string representation should be in double quotation marks. Another way is to write the number, the integer value of, for example, I want to write A. So A means 65 and B means 66. Its integer value is 66. So 65 and 66 are stored in this A variable. And if I type it as, for example, I want to find the character value of 65 and character value of B, then write it as character A and it gives me the values A and B. So the integer value of A is 65 and integer value of B is 66. So in this way we can also represent our character values. We can type any type of message in this way. Here I have tried an example of to type hello 72, 69, 76, 76, 79. These values will represent HELLO. If you want to find the size of CX, sorry, whose CX, its size is 5, meaning 5 characters are saved, and it's a 10 byte character array. We can convert string to character array. For example, I'm trying to write MATLAB and C equal to character of A. So it's converted to character by writing a command character and the string variable name. To type the date in time, just write date time and it will give us the time and the date of today. In most of the time series examples or programs, we are using this date time. To list all the reserved names in MATLAB, type is keyword. It will give us the list of all the reserved names or the commands that should not be used as a variable name. For example, if I write try, so it gives me what values you want to try. For example, I give it a name and declare another variable in this, it will give me the answers. So if I write try and give it save another variable 5, so it will give me an error, incorrect use of A. It means I cannot use try as a variable name. For representation of arrays and matrices, we can use the square brackets. But curly brackets can be used to represent cell arrays containing different type of data, character, variables, constants. My data is equal to, use the curly brackets and type here hello 1 2 3. For example, I use another function magic. The magic function represents the 2 cross 2 matrix. The curly brackets can be used to access the contents of individual cells within a cell array. It is also known as content indexing. For example, element is equal to my data, use curly brackets and write 3. So it gives me the magic 2. It's at the third index of my data. I hope you will understand the use of curly brackets and the square brackets. In MATLAB, the small brackets or parentheses can be used for several key purposes. It can be used to access the elements of arrays. For example, vector is equal to 1, 2, 3, 4. And I want to access the element of vector, the second element of vector is 2. In the same way, in multiple rows or columns, we can access the number of rows and columns. We can even use the parentheses in function declaration or in closing the input arguments. For example, there is an input 1 and input 2. So we can write it here in this way. That will give me an error because input 1 and input 2 are not predefined. So in this way we can even use the function definition to display a message and write parentheses and inside parentheses and writing a message. And parentheses can be used in representation of operations, mathematical operations or expressions. For example, write an example: x is equal to 1 by 4, 5 by 2, 5 is equal to sine x. For example, if I write a constant value in front of the sine x, it will give me an error. And it gives me the exact notation of this 5 sine x. It should be, the static should be between 5 and sine x. Here the parenthesis is also used with sine. In MATLAB, accurate notation is very important. For example, if we write like in this way, 2, b is equal to 5, c is equal to 7. So we have created 3 variables a, b, c, and there is no comma. MATLAB will not distinguish what is a, b, c, so it will create error. So a correct way is to place either comma between them or semicolon. So it generates only the C value because A and B are suppressed here. But for symbolic representation, its syntax is different. For example, we are representing A, X, and Y. It will create error. Since it is not distinguishing A, X, and Y. So one way is to either write sims with every variable, sims y. So it is one way. But its easiest form is to write a, x, and y without using the commas. As we discussed earlier, we can solve very complex equations using MATLAB in simple command lines. For example, here is an example: plus n into sqrt y. So it gives us the solution, but in symbolic representation. If we define the variables with constant values and insert in the equation, then it will solve the equation for us using a single line. In this expression, the exponential, exp, sine, and square root are built-in functions, and this should be at the right side of the expression. So if we reassign the value to a built-in function, it can create a problem. For example, it should not be given a value like in this way. So it's already defined in MATLAB. Exp is defined for exponential in MATLAB. Using solve function, we can solve numerical equations. First, clear all the workspace and then write symbolic variables. Write an equation a x squared plus b into x plus c is equal to 0. So if I write in this way, it will create error because the assignment operator is used 2 times. So here we have to use double equal sign, and here x squared. This is an algebraic equation, and we can call it an quadratic equation. So we want to solve the quadratic equation and find the solution. In the same way, we can solve a system of equations to return a solution. Instead of a single equation, let's write 2 equations using a single variable, and both the variables should be enclosed in the square brackets. A plus b plus c is equal to 1. Sorry, 2 assignment operators should be used for the second equation. So write solve equations. So it gives us the 2 values c and x. It is finding the c value. It is represented in a and b form. So it's showing 2 plus 1. And it is then inserted in this equation, this first equation, and it's solved for x. To find what is inside c and x, double click on answer, click on c value. So this is the 2 values of c, 1 minus b minus a, 1 minus b minus a. These 2 values are inserted in then x, and then it gives us these equations. In MATLAB, sometimes we need some random numbers. For this, there is a function random, and it will give us some random value. Random numbers can be generated in array forms. For example, I write 2 comma 5. It's the correct notation to define some random numbers in 2 cross 5 matrix. If I write it in this way without using comma between 2 and 5, it will give us error. If I write square brackets, again it will create error. If I write, it will create error. But in arrays, if I write, for example, a 2 comma 5, so it means to display only the element in the second row and fifth column, and array representation should be in square brackets. For example, 1 comma 2 comma 3 comma 4 comma 5 3 4 5. So it's the 2 rows and 5 columns. Sorry. Assignment operator should be used to represent arrays. We can also write it here in simple ways. If we remove the commas, but here the semicolon is important. The semicolon will move these values to the second row. So to represent or to display the second element and the element at the second row and fifth column, we should write it like in this way, and it printed us this value of the 5. And to display the whole first row and third column, right in this equation, it will print only the third column, and both these values of the first and second row will be printed. And similarly, we can write first row and whole columns. We can solve matrices in multiple ways. For example, I represent matrix 1, 2, and 3. Represent another matrix, values 4, 5, and 6. These are three rows, 1, 2, and 3. I want to add both these matrices using B matrix and represent and save these two in B. So in B matrix, the X represent the first column and Y represent the second column. I hope you all will be clear with the notation. Like for example, I am writing in this way. So it will represent the element, to display the element in the first row and the second column. And if I write in this way, it will the vector or the matrix. We can represent the vectors in another way, like starting value, column 0.1, increment value, and the final value, and write another expression x dot static sign x. So I think x is first to represent the x value. Both the x and y values are defined. X is ranging from 0 to 1. Value is incrementing in the form 0.1, and y represent the expression y is equal to x sine x. To display both the values of x and y, write square brackets x and y. It shows the two columns. The first column shows the x value, the second column represents the y value. So when we put x value is 0, its value in this expression will be 0.01. When we increment the value from 0 to 0.1, its y value will be 0.0397 and so on. You can solve these type of equations using pencil and paper and then test the results in MATLAB to verify the results. So till now we have learned how to represent the arrays and we can do matrix operation in MATLAB. For example, I represent two arrays 1, 2, 3 and B is equal to 3, 4, 5. And if I want to add, I can add these two by using the addition operator. But if I multiply both these arrays, it will create me error. Due to the incorrect dimensions. In matrix multiplication, the number of rows in the first array in the first matrix and the number of columns in the second matrix should be same. Let's change the B matrix to 3, 4, 5. It will change the row to column. Now multiply both these matrix. Its value is 26. It's the whole matrix multiplication, but even we can write in this way we can multiply the element wise multiplication, but it will also create the multiplication of element wise is of both matrices in this fashion. Like the first the one of A matrix will multiply to the first row column of 3 of B. The true value will is the second row value of A, second row and first column, the third row, the third column and the first row. Similarly, we can write in this fashion, like 1 3 are 3 and 1 4, 1 5, 6, 8 and 10, 9, 12 and 15. If you want to take the transpose of a matrix, just write using the single quotation mark. Another way is to write transpose and the variable name and it gives the same answer. For element wise transpose we can write for example, for answer I want to take the transpose of answer. So this notation can be used for element wise transposition. Element wise transpose can be easily understood if you write another matrix with 3 rows and 3 columns. And I want to transpose this matrix. The rows will be changed to column. And so A matrix is actually in this form 1, 2, 3 with transpose. And if I want to transpose it using element wise, it will give me the same answer as the above transpose. To find the square root of this matrix, let's try another example. SQRT and answer. This function will give me the square root of this matrix, but each element. We can find the determinant of the matrix using a single command. Determinant of A. I think you observe another thing, that every time I'm using the same variable name, it's updated. The new values are inserted, are saved in the workspace. So its determinant is b is equal to -3, and I can even find the inverse. C is equal to inverse of A. We can manually calculate using pen and paper. Using the inverse function, we can find the inverse of a matrix only if the matrix is a square matrix. If it is not a square matrix, then we cannot find the inverse of that type of matrix. It will give us the error. To solve a system of linear equations for x and find the value of x, we need inverse of A and we need another matrix B. So first B should be defined. Let's define the B matrix 5, 6, and 9. And now I want to find the inverse of A into B. It will give me an error because the matrix are not the square matrix. Its solution is to use a backslash using backslash between the two matrices. So it will find the x values. It will find the inverse of A and B. It will find the answers x values elements. One simple way to represent a vector without typing each number is, for example, I want to type 1 to 5 values in a single row without using brackets. And for example, I want to represent the same values but with a difference of 0.5 and 5. If we use the brackets, it will give us the same result. And for 2 rows, let's use it for 2 rows, 6 to 10. It is not the accurate matrix because it suppressed these values 1 to 5, it stored it in 5 in x, and 6 to 10 values are stored in answer. So if I write the same expression with brackets, it will give me the exact matrix. So there are some differences between these notations. In MATLAB, vectors can be represented graphically using plots. For example, to declare two vectors 2, 3, 4, 5, y is equal to 2 minus 3 minus 4 minus 6 4 5, and plot x comma y, it will generate a figure by defining the x and y values. So for x is equal to 1, y value is 2. For x is equal to 2, y value is minus 4. For x is equal to 3, y value is minus 6. So in this way it is representing the x and y values. In this figure we can select the pen and move it the figure in this way, or click on the home, so it will readjust the plot, and we can zoom in the window or zoom out, and zoom out using the minus sign. We can save this figure for our future use as figure PNG or PDF. And we can add labels to this figure by writing X label and Y label. X is equal to values. So X is labeled here. X is equal to numerical values. Y label. Y is equal to time X. For example, I write it duration in seconds or anything else. We can write the Y labels, and we can add the title to the figure. So we can add the title. If we observe the figure, we will find that Its default color is blue. We can change this color by writing, for example, in plot, I write red. For red, I will write R, and the plot color will be changed to red. So we can change any color, or we can select any color. Using help file, we can understand the plot in more detail. Like in this menu, we will find the different examples here. Create line plot, plot multiple lines, line plot from matrix. There are multiple examples in this. We can even change the line specs, line specifications like line style, color, etc. We can do multiple things. The color, how to adjust the colors, the different rotation of the colors, the line styles, the line width, how to change the line width, what values will be assigned. Normally it's 0.5 and we can change it to 1, 2, 3, 4, any value we can select. Or we can even adjust marker at different locations of the plot. So for example, I'm picking the line spec. It will move to the help file of MATLAB. So this is the simple notation, plot x, y. This is the simplest notation. We can write the line spec here, the colors, the marker, and the other things. Using help file, MATLAB can provide us a lot of help. Like here we can access the examples, how they have used the different plots in a single graph. The line spec, how to adjust the line spec, how to get the table data. This just move to the example and it will move to an example. Here are some examples are given below. Create a line plot. It is a simple line plot with two variables and it is showing the multiple lines in a simple plot figure. To quickly access this example, either select this whole example or copy the command and move to the command window. It will open the example and we can see it's a result. But another way is to copy these lines and paste it here. It will give the result. Both these lines are represented by the x variable, minus 2 pi and 2 pi. It's the x value. Y value is sinusoidal and sine and cos values. The graph shows the x limit and the y limits. The x limits are minus 2 pi to 2 pi and x limits are minus 1 to 1. So y limits are minus 1 to 1. If we see at this example, the line space is showing the value, the range of x values minus 2 pi to 2 pi, and y1 value is sinusoidal x and y2 value is cos x. So when we put these values in the plot, it will give us the plot 1 and the plot 2 in a single figure. So writing a figure is also important. If you write just a figure here, it will give us an empty figure. And let's try it again. Remove the last line and also close down this figure, and when I enter the figure it will give me the empty figure. So writing the last plot values x comma y1, x comma y2. X value is not changing, so we are changing the y values, and the same plot we can obtain. Let's move to other examples. Here is a magic function we already studied in this lecture. Here we can write different lines using the same criteria, but if you observe here, the line is different in dotted line. So all three lines are different. So their line styles is different, and the line style and the color can be changed. Here the circles define the markers at different locations. See static. Static is the style. So these are the different styles we can use in our plots. Marker indexes. We can define the markers at different instants. Like here we have defined its length 1 to 5. After every fifth point we will get a marker. Line width is important, like we can change the line width. Line width is here too. Marker size, marker edge color. Its color is edge color is blue, and marker face color is also changed. We have defined the different values for the face color. So these are the table data. Table data can be represented in this form. The subplots, we can write subplots also in this way. I will show you an example of subplot. So these are the different type of line styles, markers. We can use these type of markers, and their notation can be seen in the figures. The line colors, edge colors. So this is very important. Just read the whole page here. And the line color. For color here, we can use the codes. If you remember the codes, then you can write the codes as well, or even you can write them with their numbers. You can see its RGB triplet value is 100, and its hexadecimal color code is this one. So from this table you can write these values as well. Instead of R, you can use these as well. The different line styles we can use in our plots. Line width, marker. Yes, so there are so many important things that should be studied before learning plots accurately or in depth. Different examples can be accessed using the examples by clicking the examples in the help file. Copy these examples and practice as much as you can on these examples. You'll find many other examples as well. To distinguish the lines, we can write another command here like legend, and define each line, distinguish each line like line 1, comma, line 2. We can distinguish these lines. The legend, the blue line is showing line 1 and red line is showing line 2. So this is a simple 2D plot. For 3-dimensional surfaces, we can define 3-dimensional plots using different functions like contour and so many other functions we can use. But we will study about the plots in our next lectures in more detail using examples. We can plot a function of one variable in MATLAB as well, and it is one of the easiest way to graph a function of one variable using easy plot. But before defining the plot, let's define the symbolic representation of a. Write easy plot. For example, I'm writing a function a squared plus a, one of the simplest expression here, and write the limits of x level. So it is showing the easy plot of this function a plus a square plus 1, and the limits are -2 to 2. We can write this line by inserting single quotation mark to the function and insert OK. So here only difference we can see is it changed to a square plus a plus 1, while in the previous one it was a plus a square plus 1, while the graph limits are the same. So the exact notation is very important. Sometimes it can mislead the results. We can define the same plot using another way. For example, I am defining a value x, and then I am using a function of fx is equal to x squared plus x plus 1. Suppress the output. Now I want to define the x value, the x limit. For example, I want to define the limit to 0.25 is the difference, and from starting from -2 to 2. And now I want to plot the figure. First I will write the x value and the fx that will define the y value for the vertical axis, and this will represent the x-axis. So you can view the same result. So these are the different ways to define any type of plots using. I just try the different methods. You can even define the functions using inline command. So write the function, but the x value will be represented in this way. So this is the inline function. So you can plot this function as well in the same way. Command window is good for learning commands very quickly. We can instantly get the results. But when we learn the basics, then for examples, we should work in scripts. To access a new script, just Ctrl plus N and we will get a new script file. And we can write the different functions, the different program consisting of multiple lines. And just run the code and then we define the errors. It is very important. It is working in script file is very important. For example, to open a new script using another way is this one. Just write it here, new script, and we will find a new script. Or click on the new and go to the script and write the script. So the script files have an extension .m, and we can even call it m files. To open an existing m file in the MATLAB, visit the location where your file is saved and open .m file. If there is another file, for example, here, I want to try it like here. It's also m files. In MATLAB programs, there are .mtl files. These are the symbolic files. Symbolic files, their extension is also .slx. We will learn about it in more detail in coming sessions. So open a new an existing file, script file. We will find the whole script, and we can make changes very efficiently just by editing the values, or we can even update. We can add more lines to the program, and to run the whole lines in a single command, just write run. Change folder, the existing folder will be changed. After running, we found that here are some errors, so we can remove these errors very quickly. These are the results of the plot. So it is showing the subplots. In this way, we can also define subplots in a single plot, in a single figure. I think we have to stop the lecture today because it's too lengthy, And about the plots, we will learn about it in more detail in the coming lecture. And we will also learn about how to write the commands in script files and how to make the symbolic models from the very basic. And try to practice on the commands that we have already studied in this lecture. Practice on each command multiple times to understand each command in depth. And I will also copy the list of whole commands that we have studied today in the description of this video. So if you like the video, don't forget to like, comment, subscribe, share with your friends, and keep watching the previous videos as well that are related to MATLAB for beginners. Thank you.